Alright, I know we were gone for so long, but we're back. I had a few more things that might be interesting to do. So welcome back to the stream. So Tuco's awake, and I wanted to try doing some wiring on this robot. But the other excuse to stream immediately is I wanted to test some changes to my video setup. YouTube had been reporting these intermittent errors with the streaming format, and I just happened upon a Stack Overflow answer that gave me some workarounds for my Nginx setup that might have actually helped. So I'm keeping an eye on that, but so far it might have actually fixed it. Hello again. Tuco is just over there. There he is. Oh, this is a good sign. YouTube's indicator thing is green so far. The workaround is pretty weird. There was actually two separate workarounds in a Stack Overflow post. One was to actually patch Nginx to basically remove the RT... I keep getting RTSP and RTMP confused. I think it's RTMP. But anyway, basically in the streaming protocol, there's like an equivalent of a user agent that says, "Hi, I'm Nginx." And the patch was, oh, now it's getting me a different error. Now it's claiming that my video output is not as high bitrate as, or it says video output low. Maybe that's a timing thing or a buffering thing. I don't think that has to do with the bitrate. Well, at least I'm getting different errors now. That seems like we've got a successful stream for at least a few people out there, so... Yeah, it's interesting that I'm getting a different error now, but we'll see if that one goes away. This is usually the error that I would get when the H.264 encoder was overloaded, but it seems fine, so I don't know what's up with that. Well, I'll see if I can keep Tuco in frame a little bit. Oh, this is going to be hard. Anyway, so this is the robot in progress. We were working on the other side during the last stream where we were working on this. And I mostly put it aside so the silicone there could cure. And then I put that shell on it because I've been working on it. Oh, I just attached that to this power supply, which might have made this a little harder to move around. But this mechanical frame has a flat side on both sides, so even without the shell on, you can sit it on there for support. Anyway, I was also going to swap out some of these screws for stainless. I think it's worth it to use the stainless steel screws on the exterior because they look nice. I like the shininess that goes with this this plastic. For now, let's just take all these screws out. I should have made those wires to the power supply a little bit longer. Oh well. Alright, so this is one of the failures from the printer, but I was still using it for testing. I can chuck this. So this is what we did last time. Got all this stuff mounted and gooped up this capacitor over here. And so this is pretty much done. I do need to label these wires so we can tell what's what. And the high power stuff is not actually soldered on yet, so I still need to solder on some bigger wires to go to the power supply and just attach the motor. So we can shorten these motor wires a little bit, but I don't know, overly shorten them. I don't know, these wires are like the thinnest high power wires I'm using. These are 22 gauge for this motor that I'm running probably peak like 4 or 5 amps through. So that might be a reason to keep these short, it's just because this wire is not especially great for our peak current. Let's also maybe twist these, so I don't like having them come apart because the bigger the loop area they enclose, the more this thing is just spraying off electromagnetic interference. Oh, James says it's a very different printer. You mean the... I did use a very different printer to make that, well, the piece I just tossed aside, versus the printer I was working on stream earlier today. Yeah, let's keep the motor wire a little bit short. I'm thinking about how I might want to work on this, but like this piece doesn't really need to move around much. And if I'm doing serious maintenance on it, then either I'm going to be desoldering this wire anyway, or I'm going to be like taking out the entire power assembly by like sliding this board out and desoldering the capacitor. I mean, none of this is especially easy to disassemble, so I'm going to cut it to that length. Mikey says, love the Smurfy color scheme. Yeah, I'm having fun with the color scheme. This was partly inspired by the just some interesting colors I found from Melt Ink. Especially this kind of aqua color they have is really cool. But yeah, and then I figured, well, I want the kind of blues for the kind of larger pieces because they're really nice colors. But then I also kind of wanted something contrasting, and it felt like kind of like a danger red for the moving parts would be really nice. And then I kind of broke that with these power supply mounting brackets, but I figured it would just be nice to have more red at the bottom to contrast the rest of it. I'm going to tin these. I'm a little bit worried about strands splaying out that I can't really see once I'm soldering in that tight space. And the holes in the circuit board are so big that it'll be easy to put these through even after they're tinned. So yeah, I kind of designed the color scheme on this so that it's like pretty bright, but the color codes, I mean, like it'll be a lot more muted once the whole thing is together, and the brightness kind of roughly corresponds with kind of how, you know, it's like poison frogs. The really brightly colored ones are the more dangerous parts. So like the power supply and the moving parts and the emergency stop are red, you know. There's no light in there because it's a terrible place to solder. It would have been nice to have an access here. It's just this is actually pretty structurally important, so I didn't want to put a hole in it. There are many things that are not optimal about this design, and those mostly come out in how annoying it is to assemble. But I think it's alright for a prototype. Okay, so maybe it'll be easiest to actually attach those hot. I don't know. I'm skeptical about that. I think I want to get these, maybe I'll blue tack them into place. See, it would be kind of nice to have wire connectors for this, in theory. I just didn't like the ones this came with. I didn't feel like speccing anything out special for just a prototype like this, but like this is one of those things that you would really want to do to streamline assembly in the next revision of this, because if the idea works at all and there aren't major changes that you want to change, you know, in, like, say, you know, the way the drive mechanism works, or just like the overall size of the thing, like if it's down to nuts and bolts, then, or connectors, then yeah, that's the kind of thing that you'd want to rev, is to really think about how to make it easier to assemble with fewer steps and fewer awkward steps like this, especially. I can barely see what I'm doing in there. I think I need a different angle. Let's come in from the top, maybe? Actually, honestly, the camera's kind of in my way. Maybe I can move this to the back where it'll get a better view. Where am I doing? That's not gonna get any kind of view. Something smells just, I don't know, like some ambiguously burning something bad. And so it's like, oh, I gotta trace it to whatever malfunctioning equipment it is in my shop, but I think it's road work outside. And occasionally I get a waft of it. So it's like asphalt and stuff. You know what? I think I have a little portable light that would help with this. I'll be right back. Do maybe I don't have it handy enough for it to be worthwhile right now. I do have a flashlight. Where'd you go? Does that even help temporarily? Not really. Maybe I can just move this right light. This light is right behind the camera. And kind of in my way, but not that bad. And the filter's falling out. Let's not aim that so the filter falls out the light. Oh man, that's still so bad. Just had to reroute the cable. All right, that's about as much as I care to fuss with this. Yeah, I haven't noticed a whole lot of difference. There's a conversation about differences in different colors and how they print. I haven't noticed a lot of differences between individual colors, but like clear filament, black filament, natural filament, and single color filament will all probably be a little different just based on how they're like different grades of plastic. Yeah, I wonder if you start noticing the effects of the actual pigments that they're adding. What is going on there? Can't quite see that wetting the wire, so I'm a little suspicious of that solder joint. There's not much room for the iron without melting PLA. There we go. I think that smoking on the back was probably the hot PLA on the back side of that joint. There's like a support rail right there. It looks fine on the back. Just little solder domes. Okay. Let's prepare some wires to go in the power leads, or the power holes. Those will go a pretty short distance to the power supply here. I guess we can just use some of this 20 gauge. Maybe 2 of those. Oh, Tuco's watching the printer, the 2D printer. I think. Or are you just hanging out over there? I don't know, it's hard to tell. He gets really excited about the printer though. Like when I'm just like printing pages of stuff, he gets really interested in the paper that's coming out. All this equipment is between me and the webcam at this point. Alright, since I have all of this white silicone wire, I'm going to label it with colorful heat shrink. Let's move the light a little bit back. I don't think we need it quite at this interface anymore. I think we need to go servo AF now. And Tuco's checking out the printer over there. Don't check out that silicone, boy. Hey, Tuco. Hey, Tuco, don't bother that. Hey, I know it's interesting because it's the one thing you're not allowed to bite. Well, not quite the one thing, but it's the newest one for sure. Yeah, that light is still completely in the way, isn't it? That's better. A little bit less in my way. right. Colors. I don't know why the green is so much larger. This kit of colors is really annoying. Like, it only has red in this larger size. This size is probably too small. Is it? Just barely too small. So my color choices are basically only blue, black, and green if I want it in this size. The green is even a little bit larger than I want. And blue and black is kind of an ambiguous color scheme for this, isn't it? Blue and black. Okay, where's the rest of my heat shrink? Ah, yeah, these are better. I don't have as much of this stuff left, but it's better. Here's red and green. Those go together. Those are something that unambiguously indicates DC power, at least as far as I'm concerned. I just need a little bit. Just a little ring for each side. Just immediately rolling away. You can see I use this same strategy for the AC wires. Oh hey, my YouTube thing is green now. It's no longer complaining, giving me errors I don't know how to fix. That's cool. So that's interesting. The workaround that I put into place on the Nginx server in between my streaming machine and YouTube, I was following these two hints that I found in a Stack Overflow answer, and the answer implied that either one would work, but I just tried both of them for redundancy. One was to turn on an option which seemed to be copying the metadata from the original stream. So maybe it would say, oh, this is from OBS, and maybe basically both of these were like YouTube has blacklists and whitelists for particular stream providers. So like one option was copy the metadata from the source stream. The other option was patch the Nginx source code to basically change its identity. So instead of saying that it's Nginx, it says nothing and then just puts its Nginx version number elsewhere. And so, yeah, I put both of those into place, so I don't know which of the two fixed it, or whether I'm just if it's just luck, and like neither of those even did anything. But that's what it did, and it seems okay now. So it certainly looks like YouTube is maybe just blacklisting Nginx for some reason, or whitelisting OBS, or possibly just using blacklists and whitelists that change the behavior in ways that break it. It's hard to tell if they're being intentionally malicious or not. It's one of those bugs. Right. I'm gonna tin. Can I tin these? This is thicker wire, so I don't know if I can actually tin these. I am going to cut them shorter though, since I'm soldering them kind of blind like this. Yeah, I do like K. Temkin's attitude that never attribute to malice what could be attributed to really anything else. And yeah, so my best guess would really be that it's some kind of performance or compatibility hack gone wrong. Because when I noticed this problem starting, I don't think I changed anything on my side, but of course there could be some change I just wasn't aware of, like the video driver thing that definitely broke Twitch. Yeah, for anybody who didn't see why, or hadn't heard why, my Twitch stream, which was a new thing, it's not like I discontinued it, it just had a technical problem once. I was supposed to be streaming on Twitch, but I wasn't because of a half-complete NVIDIA driver upgrade that broke CUDA on the machine that was doing the transcoding. So I've got to do the transcodes on GPUs. I just have not had luck with having enough CPU power to do all the video transcoding I need around here. Which is great when it works. Got a little more room to solder this time. Oh, I should be getting a closer shot of this. Never attribute to malice what could better be attributed to machine learning. I like that. Oh, man. I mean... Oh, man. But what do we even mean by malice? And what would it mean for machine learning to be functionally equivalent? Oh, Tuco, what do you even... Don't do that. Hey, buddy. Okay. Tuco, we really need to keep the camera on you, and then maybe people could warn me when it looks like you're about to jump onto the soldering iron. Yeah, you see capacitors gooped down in power electronics all the time with that like white silicone stuff. And so I'm not sure exactly what the product is that's usually used commercially. People call it Celastic, but I think that's just like one specific brand name. But I had just a whole bunch of extra like bathroom caulk, which I think for my purposes is plenty good enough. Like it's resilient enough that it's not going to overly constrain the capacitor, even as things, you know, thermally expand and contract. It's plenty sticky enough; it holds really nicely. Man, that joint looked a lot nicer than this one. I'm just going to reflow this one for my paranoia. Okay. Cool. So that's approaching a working power electronics package. So I can attach these to the power supply. The next thing I want to do on this side... Well, we can also attach the e-stop switch to the power supply. Yeah, the next thing I want to do on this side is basically identifying all the smaller wires coming out of the power board. So there's a 24-volt input to the DC-DC converter that's running through the e-stop. Basically, the story behind this e-stop is I ended up using one of the cheap and plentiful e-stops because the real ones were... Well, they seemed like, I guess I didn't shop for the real ones like from, you know, actual industrial supply companies because that seemed like both way more than what I needed and like it would be super expensive. Like I don't want the e-stop button to be the most expensive part of the project. So I was looking at kind of just like some random switches that I saw online that seemed like they wouldn't be too bad. And then it turns out that Big Clive was looking at some similar switches and he took them apart, and the mechanism actually looked fine. But then when I actually tested these with some current, the contacts are not something I would trust with much current. The resistance fluctuates quite a bit as they're opening and closing. So I figured the best compromise between, all the different factors affecting safety and reliability would be to run the 24-volt power for the control electronics through this. So when you press the e-stop, when you press the e-stop, it kills the power to the microcontroller. All the input to the motor controller go to 0. Motor stops. If you wanted it more off, you yank the power from the back. That's what I got right now. I mean, obviously it would be more foolproof to use a relay, but then that's like yet another part to find space for in this contraption, which I haven't done. So this version, I'm not going to re-engineer the CAD just to add a relay for that. But, it's something to take into account for the next version. So these two leads go to the e-stop. One of them is going to go to the power supply, to one of the 24-volt positives, and the other one will just join to one of these wires. Yeah, the funny thing about these e-stops is they're most of the way to being a really nice little design, but they just skimped on the materials in the actual contacts, it looked like. So not much to say about that. Definitely not something you'd... So I wouldn't want to use them on either the, the 120 volt AC where there's potentially a decent amount of voltage across the switch as it's opening and you could get some arcing. And I wouldn't want to use it on the 24 volts DC because then you have a decent amount of current as the switch is closing because the capacitor has got to charge immediately. So in both of those situations, if you're using a switch at all, you want the switch to be rated to deal with some abuse, whereas this definitely isn't. So, and then I could have used it for something just completely like logic level control signal kind of stuff, but it seemed like the best compromise was just to use it to switch on and off the control electronics. That seems like it'll be pretty reliable. Okay, and so these are actually the wires going to the regulator. So this extra short one is the 24 volt in. And actually, let's use one of these connectors. I got these things. They're really cool. It is a butt connector, which is fun to say, but it also is fun to use. These work with heat shrink, solder, and glue all in one little package. I don't know if they'll work on both of these wire gauges I'm dealing with here. Also, since I wanted to preserve some slack in these wires so that I can service the switch later, instead of running this directly over here, I'll actually run this wire over here to a splice. So I'll probably join these there-ish, and then this wire can go to the power supply. Alright, do both of these fit in the splice? Because these are very different gauges of wire, but I think that'll be fine. So this is 20 gauge with thick insulation, and this is, what is this? 20, this is nicer insulation too, but it's 26 gauge, I think. 24 gauge. Yeah, so 24 gauge with thin insulation and 20 gauge with thick. Let's see how these do together. It is also tempting to put a little bit of heat shrink around all of these to keep them together mechanically, and then just not shrink them yet because I want to be able to tell all the wires apart. Is this too little? I think that's too little. It's another one of those situations where I think the color that I want, or the size that I want, is not available in any good colors. Well, this'll work. That'll just blend in. This is easily my least favorite heat shrink kit. All the heat shrink is super thin-walled, and it's just the worst mixture of sizes and colors. think this other stuff I got locally from Fry's Electronics ages ago. I've also got some that I just have a lot of, like, I've got a bunch of this, I think, 1/8" white heat shrink, which is pretty useful. Oh, maybe that's what I could use for this, actually. Is that too small? That might be about right. Just take a bit of the never-ending stash of 1/8" white heat shrink. Oh, now I kind of wish I knew where Tuco is. Where's Tuco? Oh, Tuco's on the rack. Oh, yeah. What a good cat. This cat is doing such a good job at being a cat. It's just one of those moments, though, where you really want a hands-free way to reorient the camera at the cat. Maybe someday I'll have one of those things. Okay. So there we have the 24-volt in. Oh yeah, I think this might be a good use of one of these splices too, because it could use some mechanical reinforcement. Is Tuco working on a butt splice too? Oh, he's a little out of focus. Oh, there's maybe a little too much light on there. That's a little better. The solder didn't wet quite as well as it usually did, and I think it's because the wire was kind of at an angle. But I think it's alright. I'll do a pull test in a sec after it cools. Yeah. So it has just like a little bead of solder in the middle that melts into both of the wires. There is some copper visible in there, like I'm wishing it had a little bit more solder. I think maybe if I wanted to, I could try doing this again with a slightly larger splice that has a larger solder bead, but I think this will probably be fine. Let's just press on and stop being such perfectionists about it. So then this I can trim to a reasonable size. Oh, such a good cat. I guess I should really just make all of these wires about the same length since they're going the same place. Maybe with a little extra on there for being able to take the switch out. But it doesn't need much. And I'm sure I'll take this off the power supply if I'm taking the switch out anyway, so I should just make it exactly the same. Alright. And just for consistency, I'm going to put the same little heat shrink label on that wire. Okay, are all of these? Those are shrunk already. This one needs to be shrunk. It's nice when you can get in and out even before the heat gun warms up enough that it has to cool down when you turn it back off. Alright. I'm going to start actually connecting this to the power supply. Although I kind of want to power this thing up off of the bench supply before hooking it up to this supply. So I'm going to avoid attaching those quite yet. I want to at least be able to verify my 5-volt output is working and the motor doesn't just like start turning automatically. Those kinds of problems would be a little easier to deal with when it's still on a bench supply. Okay, so now I've just got a bunch of other wires to try to deal with. Yeah, that did not make this part easy on myself. I think next time I do this, I'll try to do the wiring harness before putting the board in place. There are a few things I'm going to do as shortcuts when I assemble the other winches. Notably, I think I can assemble this whole bottom half of the frame before putting the motor in place, now that I know it's possible to take it on and off with the motor on. So... Okay, so here's the 5-volt output. This one's shorter than all the rest, and it goes directly to the DC-DC. This time red means 5 volts and not 24 volts. I'm sure that'll help. Okay, so we should have ground, enable, and 2 PWMs. Let's figure out which one of these is ground. Looks like this one. Yep, 0 ohms. We're basically at the level where you can kind of hotwire this thing. Like if you just had these wires coming off of the motor controller board, but you didn't have any of the microcontroller circuitry working, you could still just kind of start touching wires together to make the motor go. Okay, so one of these, I'm basically going to have to probe on the underside of this connector in this way that nobody can really see because I can't really take this out. And I mean, I can kind of get better access by rotating this, but not much. I kind of want to prop it up like this. There we go. Perfect. Okay, so I'm just going to pick one of these wires arbitrarily and then see where it goes. So I'm going to be looking for one of the 4 pins on the right side of this connector where it's actually completely hardest to reach them all. You know, the other thing I might do is just look for continuity between these and the resistors that I can probe, and just use a different motor controller for reference to see how they're wired. Also, I've got a few more of these to modify. I've only modified 2 of these so far. These motor controllers are, what is this chip again? BIN 7960. So 2 of those half bridges. They're really overkill for this design, but it's nice that they're not blowing up like the last ones that I was using. And you can get them on cheap breakout boards. The issue is the breakout boards are very badly made, and you need to kind of clean them up a little bit. But if you do that, it's a good deal. Just noticing yet another, like, some of these breakout boards have really bad misalignment in the placement of the ICs. It's not too bad on this one, but it's kind of bad. Like, it's not causing shorts, but it's visible clearly. Anyway, we already did the cleanup on this. Mostly that involved taking the messy solder splashes off the back of the board, cleaning off all the flux residue, and then putting on thermally conductive tape between the back of the board and the heatsink. There, you can see it. Because otherwise it was just scraping right up against, like, the only insulator between like 24 volts, 5 volts, and ground basically became the anodized heatsink. And maybe some solder mask if you're lucky. So, but here let's just use this as a model. I'm looking for, again, you can see these pins. These are on their way off. I just haven't taken them off yet, and they all got bent over by a previous mechanical test. Okay, so they're basically 2 groups of 4 resistors here, and the second from the right on each is the PWM. That's interesting. I don't know if the PWM and enables are... Yeah, I think... Anyway, I don't care which of the enables goes where, because I've got both of them tied together. So I should be seeing these 2 rightmost resistors tied together and to my enable pin, and then the other 2 should be the PWM. So I'm going to label the enable. The 2 PWMs are kind of arbitrary. I think that's right. That should be the enable. Is this it? Okay, what should the enable be? Should I just label this? I don't know how long I'm going to end up making these, and I think I'd rather have a color or like a band up here. Let's just use the blue for enable. Sorry about that completely being out of frame. Not too worried about identifying which PWM is which, since I think we can just reverse those easily enough if the motor's going the wrong way. I still haven't really decided which way the right way is, and it's so arbitrary at every single stage of this process that I'm not really that concerned with keeping track. Okay. So I think I can shrink this one now, which just exists to add some stability to those wires. All right. Okay, I think the next thing to do is to test the power electronics. So I'm just going to plug this into a little breadboard and just ground all the motor control signals. Test that our 5 volts is actually 5 volts. Test the e-stop switch. The purpose of this test is that if something's wrong, I don't want to blow up the microcontroller board, because that's yet another thing that I would have to replace and pay for. So I'm plugging the blue and unlabeled wires into the same rail as ground to ground the motor controller inputs, which is superfluous, but is better than them just dangling around. And then I want some headers in here so I can clip the multimeter onto the outputs. Well, actually, I don't think I'm even going to bother with that. I can just jam the multimeter probe in there. Then I'm just going to wire all of this up to the power supply. So first bench supply and then this supply. And these will go to just different screws on the power supply, but for now I'm just going to clip them both onto the alligator. Okay. So when I apply power, we should have very little current draw, just the DC-DC converter and the idle current from the motor driver. And we should be able to measure 5 volts. Okay, let's start with 9 volts. Okay, 40 milliamps. Let's check the voltage. .95. All right. Let's just get some alligators for that meter. Ow. I have some tiny ones right here. So So the meter should be reading the power that the microcontroller board will be receiving once that's actually connected. Okay, so 40 milliamps, which seems a little high, but I guess that's the idle current from the motor driver. So I'm just going to crank this up to 24. Current still about 40 milliamps. Oh, actually, you know, I determined before that that current might be a reading caused by connecting the two sides of the power supply together. Yeah, if I undo that connection, that goes away. It seems like it does that even when the second power supply is off, which is a little weird. But if because I only need to do that when I'm running at more than 3 amps. So I'm just going to disconnect that. Okay, that's better. Now it's reading like 0 amps. Okay, 24 volts off the bench supply. Now, e-stop, and that slowly decreases. It'll be a lot less slow when there's actually a circuit attached to that. All right, let's hook up the actual power supply. I'm just catching up on chat a little bit. Yeah, it would be interesting. I'm curious to see how much other applicability this project has, because I mean, you know, I've been putting a ton of work into it, mostly because I like my cat a lot and I want to get this thing working. But, you know, it would be nice if it would be, you know, not just something that I would make use of, but something that I could share. When the power supply is all the way down here, this wire seems a little short. Oh, Tuco's like escaping the frame. Oh. Now he's not in frame. Oh, thanks, Took. Yeah, Took understands the video cropping. Oh, and YouTube is still green. Okay, maybe that means I actually fixed the problem with that crazy Stack Overflow workaround. I'm gonna have to make a Stack Overflow account just so I can say that that worked for me. It was like a pretty new answer too, and not a lot of people had commented on it. is wired up, AC and DC. We've got screws in the bottom, brackets are on. Let's get these wires out of the way. And we will also have the kilowatt. Can we get this on frame? It's a shame that the plug I have this on is so deep. I kind of just want another vise right there. My one vise is holding the glue that's drying. Well, the vise that would be suitable for this at least. Alright, maybe this isn't going to have the best, maybe I'll just hold it. Alright, before I plug this in, I'm just going to double check the IC cable wiring. So we have ground in the middle. Ground. Hot. Okay, this is all fine so far. Famous last words. So then that plugs in, back there, right behind the giant capacitor. And that's in its on position. We should see 5 volts there if this all works. Alright, so 0 watts. Nothing? No DC volts? Are we missing something here? Check the... I'm going to be watching for the light on the power supply this time. 1 watt, 0 watts, no light. What's going on there? Let's take all the DC stuff off the outside. Let's also unplug this. Also roll up this spool of solder, which could turn into conductive debris. Oh, Sergei Zakharov in Twitch chat reports, all is good. That's great to hear. Okay, all the DC output's gone, so we've just got AC here. Ground, neutral, line. Just expecting to see this power LED coming on. See it. Okay, let's put the probes back on the multimeter and just check out this AC path. It was drawing like a couple watts momentarily. Ah, that's what's wrong. There's a voltage selector switch that I thought this was the power supply I was using before, but this must be one that I just took out of the box for mechanical fitting. And then I ignored this giant sticker on the top that says, look at the voltage. It's a good thing it's not the other way around where it shipped as a 110 and I'm in a 240 country, because that sure would be embarrassing. And of course, you need the tiniest, stiffest screwdriver. All right, 115 volts. Great, that's what we live in. Let's see if we get a light this time. So that's still plugged in. Let's plug in the other end. We get a light. And now it's idling at like 5 watts. Cool. Now let's hook the DC back up. Oh, and I'll reset the chat. Sorry, sometimes the browser the chat runs in gets wedged. Or the JavaScript that's running the chat, I don't know. Something along those lines. Oh, such cat. Aw, that's a pretty face. I mean, I'm such a sucker for animals. I like pretty much every animal, but cats are especially pretty. Especially those cats. Alright, so just these again. Okay. It's a little easier for the wiring. These are coming out of my breadboard. These inputs have pull-down resistors. I'm just kind of putting these here out of an extra sense of paranoia. But if I just left them, well, I don't know if I'd want to leave them anywhere, but if I like taped them to something so they're all not anywhere touching each other, then that'd be fine too, but grounding them all seems easy. Okay, so the meter is set to read the 5 volts that will be going to the microcontroller shortly. This is the power supply now. Got IEC going in there. And the e-stop is off. 5 volts. Sweet. And about the same power usage. So e-stop should cut this off. It won't cut off immediately because there's no load on the output, but it'll cut off still. It'll go down faster once we actually have a circuit on there drawing 120 milliamps. But yeah. So I could theoretically hotwire this and start driving the motor maybe, but since I've got cord on this thing, I want to be able to move the motor kind of slowly, and so I think it's better if I just actually finish wiring it up. But the power seems to work. And now that we've got the power supply wired, in fact, we could even mount the power supply, since there's no reason not to. That would make it a little easier to deal with. Okay, so for that, I think I need some M3 nuts, some M3x8s, I think. Oh, I should really check the CAD model. Yeah, I think I need to check the CAD model. See what kind of nut the power supply goes in with. This is also where it'd be nice to have a real bill of materials, but it's a prototype. Oh, I need to switch the Windows machine back over here. Does that do it? We have different garbage. That timer is never quite long enough to reliably run from wherever one monitor is plugged in to wherever the other monitor is plugged in. Okay. So... these are the screws we're talking about. Yeah, this is something I really miss. Fusion 360, I had such a hard time navigating around like inside of dense models, but here I am, I didn't have to hide anything, and I can just rotate around this screw, no problem. That's something I like. Anyway, what is that loudness outside? Distance. And actually my favorite view mode is this, but it's a little slow once the model gets this complicated. I think we want... oh, there we go. I had project turned on and I didn't mean to. Could also turn on some selection filters. There we go. 8 millimeters. Okay. M3x8 screw. Let's have the UV upright. It's actually funny how much faster, like, fully rendered with shadows is. Oh, I guess it isn't on this model. I'm actually used to this mode being faster than wireframe. But I guess here it's pretty slow too. If I turn on just the shell, it speeds up. Yeah, it's much easier to navigate inside of objects with this particular Space Mouse driver. If you see this little blue cursor pop up, anytime I touch the Space Mouse, it kind of decides where the center of rotation should be, and it holds that for the length of that particular grab, but then when I let go, it can recenter to some other object. And once you get used to that, you can actually drive around like inside and around fairly large objects with this pretty easily. And fly through his eyes. Whee! You can start to see the resolution artifacts in the shadow. Anyway, it'll be nice to actually have that part. Printer's busy. Okay, M3x8. 3 nuts. This uses the construction where there's a slot for the nut hole. And I've had a lot of luck actually with making these easier to assemble by putting the nut in, making sure it's aligned right by having a screw in there, and then actually just like filling behind the nut with glue so the nut doesn't fall out. and using a flexible glue like E6000. So even though I'm about to assemble this, I think I'm going to do that anyway. I don't think the glue will get in the way, and I think it'll help later when I'm reassembling this. I left plenty of room for these screws to go really deeper than they need to. Wow. Yeah. I think in the CAD model I have M8 screws, but these could accommodate much longer screws if they needed to. So I'm going to get some E6000. It's already close by. This is totally the wrong angle to get on camera here. Basically just squirting them in this hole. When you do this, I usually try to overlap the nozzle of the tube that I'm squirting with about half the hole, so that the other half is free for air to come out, and then you kind of like fill the hole from the bottom. Okay, so I'm going to leave those alone for just a sec and concentrate on the other side. I keep putting stuff away between projects, like putting all these little bins back on the other side of the room, but I'm going to keep having to bring them back over. These take M3 by 35 screws, and I have these really nice stainless steel ones. They're really nice, except that they don't seem to quite fit the ball drivers I have, which is annoying. Oh, I think the chat is stuck again. I need to reset that. Sorry about my buggy web stuff, folks. Whoops. So this throws me for a loop when, like, I open the dialog with the preferences, and then I click refresh, and it refreshes. And then I close the dialog, and then sometimes it also refreshes, which is a little annoying. You know what? Burritos. They're pretty good. I might have to get a burrito at some point today. Alright, that's about as far I want to put it on until actually getting that nearby. I mean, the power supply can go on much later. I could do all the wiring on the other side before putting the power supply on, but I kind of want to put the power supply on, and I don't think it'll get in the way of doing the other wiring. Oh yeah, James says that it's been doing that a bit for me. I think it's a problem with the images. You mean like in your Gitter client? Yeah, I think it's possible it's just a bug in the Gitter UI, like their JavaScript code. I just haven't found where to work around it yet, and I think really the proper solution is to write my own kind of client thing that draws the chat on there. Right now it's basically a CSS hack on top of the regular Gitter UI. And it kind of works, but only kind of. Okay, I think I just need to remove these screws now. And And hopefully that glue won't get too, well, I mean, I'm not going to move the nut. I don't think I'm going to have to worry about the glue pulling the nut out of place just in the next few seconds. Oh yeah, James said such pretty garbage. I assume that meant the video grabber between frames. Yeah, it is interesting. I think I'm just getting like unclear DRAM from inside the video grabber chip, because it's just got like an FPGA and some DRAM and a USB 3 interface, and I think it just scans out memory and doesn't clear it between modes or something. So we're just seeing some mixture of data from other modes and just outright garbage. Is there room for that? I don't know if I want these wires to be inside or outside that. I think I want them to be outside. I might zip tie this over here. I don't know. I don't think it leaves the AC wires a whole ton of room. Let's try putting this in. Yeah, there's not much room on the inside of that bracket, and it would mean the AC wire is passing like right next to the motor driver PCB, which I'd rather not have to force. So let's just do it this way. Oh, neat. Is that an ant made from parts? That's fun. I'm gonna kind of wonder if the screw is getting where it's supposed to be. It feels, oh yeah, it's making progress. Just slip a nut on the other end. This is one of the rare cases where the nut isn't in some kind of weird blind hole. It's just on the other side of a flat piece of material, which is kind of refreshing. Oh, James says to add some JS that scrolls to the bottom every few seconds regardless. Yeah, that might be a decent workaround. There's so much going on in there already that I just hadn't gotten around to reverse engineering which things were relevant, but maybe I don't even have to look at their JavaScript. Maybe I can just add something that adds a new event handler or something. Oh, I didn't realize you'd be able to see the label on the motor, because the back of the motor gearbox is exposed, and that also happens to be where the manufacturer label for the motor went. I think these screws are vetoed. They're not really the shape. I don't want a button head screw, I want like a square-headed screw. Yeah, let's try these. Yeah, I think that's right. The pan head screws have a slightly wider head, and I wasn't planning on that, so the screw head type here is actually important. Okay. That's done. Let's look at the other side, power supply mount. Oh man, I spent so long in CAD agonizing over how to mount this power supply, and I'm actually kind of happy with the solution I came up with. Like, it is pretty strong in the ways that it needs to be strong and doesn't require tons of extra plastic. And because part of the limitation here is, you know, I wanted to line up with at least one of the sets of screws down here so that I can retain the power supply from sliding in that axis. But having the rings around the supply meant that, you know, I didn't have to just rely on the screws for that. And so right here, I could just kind of, like there were a lot of places I could have had this land, so I could just line it up with the screws on the power supply. Whereas over here, I couldn't reach the screws quite because I needed room for the wall mounting bracket to come in over here. So instead, I just moved it to the edge, like kind of the furthest structurally relevant place that I could get it, and then just had it be kind of a ring that retained the power supply. Oh, James says I like the nut earrings. Yeah, thanks. That's kind of been my thing for a while. I experimented with a lot of different things, but then these I just didn't want to give them up. Although I've thought about making a version with like an LED inside, maybe. There's probably enough room inside for an LED. Yeah. Okay, this is like my first time seeing the power supply actually fully mounted. The power supply itself actually rattles very slightly because there's like a insulator under the circuit board, but oh man, this thing looks kind of sinister. Like all the screw terminals in the front are teeth. Okay, so on, how am I getting this wiring over? Is there anything I can do to tidy up the wiring on this side before we focus on the other side? I think having a zip tie there might actually be nice. Oh, I actually added a slot for a zip tie right there, so let's see what we can do. So, don't want to tighten that at all really, but just something to loosely hold those wires down. And then, I'm not going to do anything with the motor wire, except make sure that it's got plenty of room, but there's a couple of millimeters of space for it to hang out in, and the wire is so thin that it can just do that, and it's fine. There's a pretty big place for the motor to hang out in down there. Then, okay, so the low voltage control signals. I kind of just want those to run in this channel right behind where the e-stop wires come out. Yeah, right down there. Making the coloring on the wires not especially visible, but it's okay. It's better than trying to trace them all the way back to the motor driver board. So that'll be fine to deal with on the other side. Now these. I think I maybe want like a zip tie down there and then something up here. I guess this zip tie will cover the the power input and the motor wires. Just because that's what's here. I kind of left room for 2 zip ties. I wasn't really sure what I would be doing with the wire or the cable management. You can tell that I didn't plan the cable management in CAD, really. It's approaching about as much as I want to do. The shell is gonna, I mean, I don't know how much I want to rely on the shell to keep the wires at bay. I kind of want to anchor this down somewhere. I could just tie it to the power supply housing a little bit. Oh, sorry. These 2 wires are not necessarily in the right, I mean, they're passing over the 120 volt wires in this way that's a little bit annoying. But if I zip tie those all together, then they actually kind of keep the 120 volt wires down too. Yeah, I think a combination of bending and zip tying will fix this problem. All right. There's that. Okay, so now we're going to start needing the pinout diagram for this. Is there any more prep we can do? I still haven't decided how I feel about these little breadboard header wires. They're extremely badly made, but for some of this it doesn't really matter that much. I don't know, if these came off, that would not be so great, but I mean, I'd want there to be firmware safeguards for losing censored readings anyway, so that wouldn't necessarily be the end of the world. Plenty of other things for that. But also, I want to leave plenty of slack in these 2 wires because they kind of go through this whole mechanism, and I need that slack to disassemble this thing partially. So my plan for that was to actually kind of bundle them up under here with one of these many places I have to zip tie wires down. And so I don't necessarily need to do anything with these terminations. I can probably just use these as is. These, on the other hand, I might want to solder on. They're also a little short. Looking for where the closest power would be to actually solder this on. Okay, these are the 2 power wires. The motor drive wires I could potentially just use the breadboard connectors with too, because that makes them a little more flexible, you know, in case I want to move things around. And if one of those comes loose, then it just means the motor isn't working, because they have pull downs. So that's fine. I'll probably splice these then to some breadboard leads and use that. But the power, I think I might want to solder that on directly, or at least use a nicer pin connector for it. The other thing is, the legend on the back of this board is not really visible, so here's another board. This is the one that has a bad microcontroller on it. This is the one that was connected when I blew out the last motor driver, and it also blew out the micro one here. Okay, so I'm just looking for 5 volts and ground, physically close to where I've got these handy. And I think we got it. That is, top left is 5 volts, one right next to it is ground. So yeah, for that, I think I might just cut these to be about the same length, solder them with heat shrink, so that I have a nice solid connection there. Might be nice to see how quickly the e-stop actually causes a power down once the micro is connected. Gotta use my stash of actually good heat shrink while it lasts. like it's gonna go bad or something. No, I just gotta enjoy it while I have it, you know? Like if I just save this for special occasions, then it's gonna go to waste. I'm actually having trouble finding the diameter I was looking for. Is this it? Yeah. Got some cat hair with that one. Alright, let's prep this with some colorful heat shrink. Gonna make extra sure I'm dealing with the green and the red wires here. This heat shrink, I need to put some tape on this. Keep the heat shrink from falling down too far. Okay, 5's on the left, ground's on the right. Every scanlime project contains a bit of Tuco DNA for sure. Yeah, at least recently. I mean, Tuco and I haven't been together that long. Most of his life at this point, but not most of mine. Sure has been nice knowing him, though. Oh, that is so bright. I am not succeeding at holding that without moving it. Oh, or not having my hand take up the entire frame. Let's try it this way. Doing it this way, you will burn your hands a little bit. Just a little bit. But it's a little gentler on the insulation than the tweezers. Okay. Great. Now these other 3 wires, let's find some pin headers to plug those into. More of these terrible breadboard header contraptions. Do I have any that are less terrible? I wonder if these are any better. More of those. Okay, so I had these 2 different kinds. Maybe they're not actually different. Yeah, actually maybe these are the same. Maybe some of these just have been used a lot more than the others. I think these are the ones that seem most likely to not be awful, but how much actual copper do I get in here? Let's just take one of these apart. Man. Where's the copper? There's like 2 strands in there. Oh yeah, so we looked at these before, and I tried running some current through them, and the wire insulation got melty. And I was realizing I missed a comment where somebody asked me to do the flame test to see if they are actually copper or aluminum. And I missed that, so maybe we'll do that now. Let's strip more than that. So yeah, look how little that conductor is. Oh, actually, that's better than I expected, actually. Are these the same as the other ones I have? Here's a different kind. These look pretty similar. can count the strands, actually. Looks like 7 strands. Yeah, they both seem to be 7 strands. Okay, so I think I just have one kind here. Alright, let's bundle those together a bit at least. So let's try to do the lighter test. Let's clear a little bit of room and get a lighter. Does this lighter work? Cool. Kind of balling up at the ends. I don't know if that's normal for very thin gauge copper, but that's not a great sign. Let's try that with some wire that I know is copper, but like really thin copper. This is 32 gauge. Yeah, that's oxidizing, but not balling up even in the slightest. So that does seem like that wire we have is a tiny bit of aluminum. Wonderful. Can we burn it anymore? Yeah. Man, okay. I feel bad using this even for data signals. Like, it's probably fine. But it's just like, just barely counts as wire, really. But they were cheap, and that's why I've got a lot of them. All right. Well, do I have any that suck less? Or am I just going to do all these direct wired? Well, where do these go? Maybe it's time to look at a wiring diagram and see how much length I need. Lens says data residence being sent over aluminum. I mean, I guess it depends. What I'm saying, I guess, are high impedance, low speed signals might be fine with this, which is a lot of what I'm dealing with here. But yeah, that wire is pretty bad. Let's find a let's find a wiring diagram. Motor enable, so these go PF 1, 2, and 3. Oh, there you are. You know, those might be close enough I could actually just solder them directly. Where did Tuco go? Alright, here's the motor enable. This goes to PF1, which is right there on the legend. So bottom left on the top connector, which easily fits, and the other ones are just right next door to it. So let's just do that. So this one I already decided it's blue. Let's get the other piece of blue heat shrink. And yeah, that's just bottom left. Okay. So the motor firmware right now is still open loop, so we should be able to start testing the motor as soon as we actually get this soldered up. We don't even need to plug in the sensors, although we could. I'm still undecided about whether to use the existing sensor leads that I prepped that use this aluminum monstrosity, or to just do something else. Alright, so then PF2 and PF3 are just its neighbors, and those can go to these next two pins in somewhat arbitrary order. I should probably buzz it out with the multimeter though, and at least make the order consistent so that it's really easy to make all the winches the same, otherwise it's going to drive me crazy later. So, how am I going to do that? Oh, did I want to do it that way? I think I wanted that to be under. To be under that wiring harness too, or that bundle of wires too. Yeah, I think that's what I want. that seems better. So. So I was keeping the motor polarity consistent by just matching the colors on the motor cable to the plus and minus on the driver, even though those are both completely arbitrary. It's just nice to match them. For the PWMs, am I just going to make the left one the first channel? Is that how I'm going to do this? I mean, I've hooked this up before, but I haven't really bothered deciding which orientation is the correct one, since it didn't really matter. Okay, got wires accessible. So, I'm just going to be looking at which of the two H-bridge chips these go to, or half-bridge chips. And they won't go to the half-bridge directly, but I mean they'll go to these pull-ups that are near the chip. Okay. I'm going to decide that the leftmost one, which is also the one that's easy to reach with the multimeter, is the first channel. Yeah. Let's put a piece of tape on that wire. Okay, maybe next time I'll have a color code that makes that wire separate, because I do think I need to keep track of that. Oh yeah, it's nice having this thing be more together, because it's certainly easier to work on. Okay, PWMA is what this is going to be known as. I guess I'll just use yellow for both of these. Okay, now in order to keep these wires separate, I'm about to take the tape flag off, but the one that I'm not working with, I'm just going to put back here. And then this one, take off the tape, put on the heat shrink, get it away from the joint, and then tin the wire. I was debating whether it would be worth it to have basically like a plug-in header for all of that just like fits directly onto each of these 4 headers and do it that way. It just didn't quite seem worth doing it that way, since the wires are so spread out everywhere. I mean, if I figured I'd have to replace this board at all, then maybe it would be. I mean, I think if we're getting out of the phase of prototyping and into, like, I want to make a bunch of these, I'm making a circuit board for it. There we go. Piece of heat shrink is a little longer than the turn radius I actually have. Alright. One more motor wire. Oh man, this wire, and then we can drive this thing around with an Xbox controller. There we go. All little insulating sleeves on there. I can take off more of this temporary tape. There we go. Tape. Oh, Tuco was under the desk. I didn't even see him. Okay. I think we can try testing this thing a little. So, also it sits on its legs now, which is pretty cool. Okay. So, the cord, we gotta keep this out of the way a little bit, and watch for conductive debris around the high voltage, of course, and keep these two wires out of the way. Let's maybe turn this so we can see the lights on the microcontroller board. And give it Ethernet. And we should go ahead and get the control software ready for this, which is on the other computer. Oh, good question from Sam, who asks where those other wires go. Those go to the same microcontroller board. I just wanted to save those until after I run a quick test to just do this incrementally. I'm going to test the motor, and then we can finish wiring that up. I already have a Raspberry Pi set up to send out the signals we're looking for. Okay, so in this test, there's an Xbox remote, well, Xbox controller, which communicates wirelessly to the USB dongle that's plugged into the Raspberry Pi, which sees it as a joystick. So that's the Microsoft wireless adapter. And then I'm still currently using this old test program, winchtester.py. Let's get that more on the screen. So this uses some little joystick primitives that we have to give us just like some raw XY from the joystick. And it maps the y-axis to velocity and sends out UDP packets. And we're assuming this is the winch 10.32.0.10. So let's go ahead and run this. It'll be sending out packets even though nobody's listening. You can see that change as I move the joystick. Okay, and so with that running, now I think we're ready to apply power and see if this thing operates correctly. Okay. So let's plug this IEC cable into the other side. Okay, so when I plug this in, the microcontroller should get power. You should see some green lights on the side of this. If they're even visible, will they be visible? Yeah, they're right up there, so you should see the green lights. And then I should be able to move this with the stick. And let's have the kilowatt handy. Six watts, 5 watts. I did not see the lights, which is not a good sign. So I unplugged it. What could be causing that? Oh, I haven't actually done the heat shrink yet for the power, but that's fine. Yeah, so that's coming in as 5, and we'll also see this. There's another green light that might be a little bit occluded for you right now, but oh, Sarah says, hi, Micah, I had to go. Hi, Sarah. Yeah, so we should see another power light right down there. Let's see if we get voltage. I'm just going to hook the meter up to that same couple of nodes. Maybe I can grab 5 volts and ground from a different spot on this board. Yeah, same pinouts on the next connector over. reasonably sure those aren't shorted. I can use the meter to find out before we do the voltage test. Yeah, not shorted. Okay, I'm gonna power this up again and watch the voltmeter. Also 0 volts. Wondering if this is related to the e-stop or... I mean, I can buzz that out with the multimeter. Make sure the power is trying to get there. Yeah, that's fine. Oh man, that card comes out of the camera pretty warm. Alright. Okay, so this is not plugged in to power. I should get continuity between 5 volts on the micro and 5 volts on the regulator, well, on the DC-DC. Would help if the meter is in continuity mode. Yeah, okay. Should also get continuity between the 24 volt power output and the input to the DC-DC. That seemed right. Get a more solid read on that. Awkward probe angle. I mean, I know what's connected, I just wanted a solid probe connection for testing the e-stop next. The way I'm touching this, I'm basically always going to be shorting out ground also. Is that the beep I'm hearing? Is that shorting out ground? This certainly could be a problem with that heat shrink butt connector I was excited about using that didn't quite have enough solder in the middle. But I doubt it would be completely open like this. Well, maybe I just need to... I need like a bent probe. I was thinking like grab something like an alligator clip and attach that to the meter. I'd also potentially use a bent pair of tweezers. Oh yeah, these might do. This alligator clip a pair of tweezers to the meter probe. Okay. Maybe this is the problem. So I think I might have been hitting ground and getting an intermediate or an intermittent connection due to the capacitance between ground and 24 volts. Yeah. Okay, well maybe I will take apart that splice I was so happy about. Bradley asks if the 24 volt might be shorted. I don't think it's shorted. I mean, I can check, but yeah, because it just won't power up if the output's shorted. Yeah, the output's not shorted. It looks like a short momentarily to the multimeter, but then it clears and the resistance climbs, which is what you'd expect from a capacitor. Yeah, I might undo that splice. Actually, I bet I can poke through the splice and check which side of the connection the problem's on. It's no longer watertight, oh no. That's weird. I'm reading, so I just like poked into the middle of that splice, and between that and plus 24, I'm reading like 600 ohms. And then what? With the e-stop off, what happened there? So it's 600 ohms when the e-stop is closed. Or sorry, when it's open. Oh, have I just been using this wrong? Have I just been failing to reset the e-stop? Is that? I'm still not quite sure I trust this connection though, because that's like 18 ohms. Where is that resistance coming from? Yeah, let's redo the splice. I don't think it worked with this gauge of wire. I mean, I think I was making stupid mistakes with the state of the e-stop switch in also, but I think that caused me to notice this resistance problem. So let's fix that and then fix the state of the switch. Yeah, I think I was just having those moments where like, oh yeah, I've got to push the switch to turn it on. Wait, no, that's not how this works. Let's fix the splice. I think this is just not a great splice. I have some of these heat shrink butt connectors that are designed for heavier gauge wire, but since I don't have that much wire left before I have to start fixing the other end of this connection, I'm gonna just do something that I know works. Can I just strip it with this on there? No. Yeah, that like band of glue that melts onto the wire insulation is pretty tenacious. We'll have to cut it right below that, or at least strip that off somehow. I think if I use a non-automatic wire stripper, it'll handle that. What? Oh, I was reading that gauge upside down and used it completely in the wrong setting. Sorry, wire. I'm not planning on removing as much of you as I just did. Well, at least the video works. As I nervously look over at the encoder to make sure the video is still working. Can't win them all, but maybe on a good day you can win some of them. Speaking of some of them, we can do better with this camera. Oh, that's a good hint from Bradley, who says their pal used to call E-stop buttons backwards buttons. Yeah, that's helpful. I would think it would be something so simple I wouldn't constantly get it wrong, but you know, never underestimate how easy it is for me to constantly get something wrong. Don't really quite have enough space to do a strong splice here, do I? Actually, I probably could have done better than that, couldn't I? By folding these over. It's a bit too late once the wire's tinned, but I'm not super worried about, like, I mean, this wire is not going to be under tension, but better than nothing, right? Gotten so used to messing with wire in such a tight space that I don't usually do like the really long splices, like the lineman splice and all the classic stuff, you know. I'm usually more just like stick it on in the tiny space you have with the tweezers. Oh, you know, I guess while I was redoing that, I could have, I don't know if I want to do that though. I was thinking about moving it relative to these AC wires that are still a bit in the way, but maybe I'll just tie down these AC wires. Same way I did the other ones. This is just to kind of hold down the 120 volt wires that otherwise would be putting some pressure on this whole assembly. Okay. I think we can do this. do these. Okay. Let's test that again with the meter, and then try to use the e-stop button correctly. Okay, so the e-stop is not stopped. I'm not making a good connection there. Let's try the... That's the other thing, is I was trying to probe this like right on the regulator, but the front side has epoxy on it and the back side is hard to get to. Okay, so this isn't making the most amazing connection, but let's use this for testing at least to see if it's kind of working, and then we can maybe try to get a better connection. I wonder how much of this is the switch contact being terrible. Okay, this is not really helping that much. I'm just going to try powering it up and measuring the voltage. James is asking if that's a capacitor. It might have been a capacitor and... because the thing I was trying to measure is basically, well, it should be really low resistance, but it might be that I was getting a bad connection to that, but then there's also some capacitance. I don't know. Okay, that's the 5 volts. Okay, the sensor wires are out of the way. The e-stop is released. Conductive debris rolled away. Figuring out which orientation the IEC cable is supposed to be in. There we go. Okay, let's plug this in again. Contact. Oh, there we have light. That's better. And then e-stop and the micro is pretty much off immediately. And then it comes back on. Oh, you probably can't see the lower LED. That makes a little more sense. The upper LED comes on after the software is booted, but the bottom LED is like the main power light. Okay. Let's see if we can run the motor a little bit. It should be listening right now. Let's give it a little tension. Maybe I have to turn on the joystick. Whoa. It's always nerve-wracking when the joystick powers up and doesn't quite know where the center position is. Okay. That seems pretty good so far. Let me get the kilowatt in shot too. Oh, I know this is going to send screws all over the place if this falls. Trying to remember not to decelerate so sharply. I don't think I tripped the overvolt, but that was certainly a danger. I'm still just sending raw commands to the PWM. There's a whole control loop that goes on here that I haven't quite written yet. Part of the reason I wanted to put this together was so that I could get around to doing that. You can see how it's pretty easy for me to get this thing to pick itself up without any of the mechanical anchoring. I'm just running the motor super gentle because this is just sitting on the desk covered in high voltage and exposed wires. But yeah, let's take it over to the other side of the room and actually mount it maybe. Unplug this. Well, I think I'm getting ahead of myself. Let's finish attaching the sensors, and then let's make sure the sensors work, and then take it over to the other side. It is almost done, but it does not have sensors right now. It is looking a lot like a winch bot, isn't it? It is nice having it be in any sort of self-contained form like this. Yeah, that's looking good. So there's the power electronics doing their thing, moving the motor. Big ol' e-stop kind of working. Oh, I haven't really shown this view much, but this is the connectors in the back. You've got the IEC power and the RJ45. And that's what I was saying earlier. You can kind of see the branding on the motor still. 24 volts. Yeah. Okay. So let's work on this side a little more. So we've established that these little breadboard jumper things are really bad. Excuse me. They have a tiny shred of aluminum in there. It's tempting to replace them. I don't actually know if it's necessary though. And I've already built this little thing that has all the resistors and stuff I need in it. So maybe I'll just plug this in and do that. Oh yeah, Bradley points out something too that I'm pretty pleased with, that it seems to be running pretty smooth without any weird like eccentricities or cogging, and yeah, I'm very happy with that. I think I got away without the cogging due to the, like I think both having flexible gears and helical gears helps reduce that. But yeah, the lack of like weird wobbles, I feel pretty happy about that. I was very worried about that during the design. Clearly, everything needs to be on a different computer. Gotta go over to the Windows machine where I have the pinout loaded. All right, oops. So this is what we're working on. So winch, we still need to connect the encoder and HX711 pins. Each of those also has power and ground. And they both run off of 3.3 volts. It is depressing that those sensors are getting their power through this shred of aluminum, but they are so low power that I could power them through a 100 ohm resistor and it wouldn't really matter. And these cables aren't quite that bad. Okay, I still need another little model board that actually, where's my board that oh, here it is. Board that has the pin out on it. So, let's start with the HX711 maybe. So red and green are the power. We should put those near the data. Where did the data go? It's PQ0 is the clock. These I'll definitely want to test. Make sure that I got all the wiring right and it's getting data. PQ0. So these are connecting to one of the SPI ports. The HX711 speaks kind of a weird protocol that is kind of like SPI. It's close enough that I can use the SPI hardware to speak it at least. It's kind of notably weird in that the number of particular clocks you send out matters, and it has to be kind of a weird number like 27. So PQ3. Oh, there it is. It goes way up here. Yeah, so for these, I'm going to want to plug them in, then run the telemetry program to like just test that the right values are being read from these and sent back out over UDP. And then once I've confirmed that, I'll just make it, like bundle up the wiring and make it just tidy with zip ties. Is that right? PQ0, PQ3, 3.3 volts is up there. Oh no, it's way down here. Okay, that should be the HX711. 3.3 volt power clock data. Then this is the quadrature sensor. So this is basically LEDs and phototransistors on the other end. And in this little wad of heat shrink, I added some pull-up resistors. So this has a similar pinout, where red and green are 3.3 volts. This has a pretty wide voltage range it'll run off of, but 3.3 volts seems fine. And so these, do I have a spare ground? Yeah, there are luckily a few spare grounds on here. just barely have enough grounds for this whole contraption, though. I mean, I could solder more grounds to this, but it works out that way. It would actually save me some frustration to pull up a diagram, maybe that I don't have to keep mentally flipping, but I'm almost done with this. So that was ground. Then we need one more 3.3 volt. That'll be down here. And those two just go to the quadrature PL1 and PL2. Oh, I also forget which of these I decided was which. This might be something that I get backwards in the other winches and have to fix. Yeah, this is going to be very arbitrary. It seems like I should set up this coordinate system so that, you know, like the motor and the encoder have the same polarity. That'll all be easier to figure out once I have slightly more software support for this whole thing. Just double check that. PL1, PL2. Yeah. Okay, I think that's fine. Let's test it. I'm going to just sit this up so that I can make sure there's no conductive debris. Hey, Tuco. Okay, so telemetry. Okay, this will start spewing data to the console once I plug this in, hopefully. Oh, Tuco, stay away from this, honey. No, stay away from this, Tuco. This is high voltage. No, elsewhere. Alright, that's working. This is literally the next thing I need to do is fix this so that it's less terrible by writing tons of software. But, okay, this is the column where it's reading the encoder. That looks right. And then, is that the force sensor? Yes. So you can see it going more negative, then zeroing out, and then going more positive. Okay. Let's put on a zip tie and then stick this on the wall. Oh, Tuco, just on cue. Imagine that. Tuco, you're so good at being on camera. Is Tuco not quite framed right? I can move the camera a little. Perfect. places to put zip ties. I don't have to do this all with one zip tie. Maybe I just use one for each sensor. You know, I don't know if I want to grab the ribbon cable itself. It seems delicate. Maybe I just have this go around the sturdy part, and then I bundle up the other part more gently. I mean, I could do that, get these out of the way. Are we on plan B or plan C or plan E1/2? Plan H.2 maybe. I think I'm gonna have these wires go under that red thing. With all this replugging, I'm definitely going to test it again before going to the other side of the room, because it's easier here, but yeah, wires. Alright, so that zip tie is a little bit snug, and that'll just hold the heat shrunk parts with all the joints. And then this, I'm just going to try to bundle it up semi-neatly. And the thing is that the cable for the optical sensor is just so much more rigid than the other that they're a little bit strange to bundle together. Yeah, maybe those two get separate zip ties. That can handle some tension and kind of needs it because it's so heavy, whereas this stuff is kind of delicate. And Might even respond better to tape than zip tie, but I don't really trust tape to stay on, so I'm just going to be gentle with the zip tie. Okay. I don't know if this is necessary, but it might be nice to have to kind of loop these onto each other. Just to have them be a little less floppy. All right. So those are all the crimes that are getting hidden over with the shell once that finishes printing, which isn't terrible. I mean, I couldn't be too cavalier about this, given that it's translucent. All right, let's give the sensors one more test. Contact. All right. Yeah, there's the load cell. There's the encoder. Great. $7 idle. All right. Now for some mechanical mounting for this test. I'm just going to attach it to that mount that I've screwed onto the crate thing over there. Might be a little hard to hear me when I'm over there, but I'll try to do the important talking when I'm on this side of the room. Maybe autofocus. Right. Getting a little bit of that sunset, nice golden light coming in. Yeah, corn tact. All right. That's right, I turned off autofocus. Oh well. I am quite pleased with how easy this thing is to mount. So there's that, and then you need a pulley. Oh, take the sandbags off the pulley. I need to do a little wiring. Okay, I was using this really short Ethernet cable, but I'm gonna need a longer one for this test. I don't actually have a really long patch cable handy, so I might have to string together a couple of these short ones. Hopefully we won't have signal integrity problems. It's using... Oh, why is that so overexposed? Let's at least go back to autofocus for this. How far does that get us? We also could use some more light, right? I don't know if that's super helpful right now. AC power, and then we can start moving stuff. Hopefully up and down. All right, I'm gonna plug this in. It's got lights. You might be able to see the green light. These things are gonna be somewhat bright green unless I actually do something about that, aren't they? I was going to add some interior addressable LEDs, but there's also gonna be these bright green things. Some sandbags back on the... I'm putting these back on the mount that's holding the pulley. Lay it down. Now let's try to get joystick control back. So I'm getting telemetry, which means our network is good. Control C the telemetry if I can. Yeah. Oh, let's wake up the joystick and then turn this on. It is still a little nerve-wracking having the joystick mapped directly to the PWM without any of the software safety features I plan on having. But okay, that should be good. All right. So we have winching and unwinching. So I'm going to unwinch enough cord that I can run this through the pulley. Oh, I really could use a better camera angle for this. Okay, so this is roughly aimed right. I can tilt this whole thing. I want to be a little careful about grabbing it before it has the shell on when it's plugged in, but yeah, basically I can swivel this on the wall mount to aim it at this pulley if necessary. And then on this end, let's hang something, some test weight. I've been using this spool of wire that's about 1.5 kilograms. Okay. That 1.5 kilogram weight is attached. Hey cat, Tuco's right here on the floor. Well, that's pretty good so far. Thought I heard a noise from this, but it's from outside. Kind of buzzing noise. Pretty sure that's outside. Yeah, okay. Hazards of living in an industrial zone. Is that my motor or someone else's motor? So yeah, I mean, I'm trying to be a little ginger with it without some of the control system features that I would like to rely on, like monitoring the force sensor and accelerating and decelerating slowly. But yeah, this seems pretty working. And a lot of the wobble I was getting in the bot itself from before totally has gone away now that I have a better support bracket for it. Let's see if I can get a better view of the winch itself from all the way over here. Oh, what is Tuco doing? Tuco, are you checking out the optical encoders? Oh, he's also hunting moth. There's a little moth. Oh, it'd be nice if I could easily get this camera on the side of that bot. I don't know how much, this is always what happens. I have this camera set up great for my desk, but then if I want to do anything that isn't the desk, then it's like, oh, how much do I want to fuss around with the camera to get that on video? Actually, maybe I should just stick this on a tripod. Stealing a tripod. Just a moment. It's probably less terrible when I don't have it super zoomed in and I'm holding it. is a pretty light tripod, and you can just see it settle under the camera's weight. Okay, can I deal with that? Where did I even put the controller now? I think the camera's fine. Now I'm just misplacing the Xbox controller. Oh, on the heater, of course. Okay, so there's a little bit of wobble in the spool that you can see, but well within what the design can handle, I think. Oh, I should try the e-stop. I'm going to try e-stopping while it's lifting. And it just stops. Great. And now it's back. I'm going to try the same while it's unlifting, while it's decelerating. Okay, so it's lifting again. Okay, now it's at the top, and while it's on the way down, I'm going to e-stop. Great. It just disables the motor and it coasts. Cool. Well, I know the camera angle is pretty limited right now. Maybe I'll go handheld and use my phone to capture some more close-up footage. Because this is probably the least interesting angle we could be watching the winch from. Of course, my phone has this problem now where the orientation sensor is pretty much completely unreliable, so we'll see if I can actually get it in landscape mode. Is that right? Oh, it was detecting now. Maybe if I unlock the orientation, it'll actually work. I had the orientation locked because it was usually wrong. Okay. Where'd she go? was, I think, full speed at lifting 1.5 kilograms. And that's full speed at decelerating, or is not decelerating, at lowering, I guess is the word I'm looking for. Alright, well maybe that's a good stopping point for the stream. I think that feels pretty nice. We've got a winch that kind of even works. Oh, maybe while I'm mobile we should check on the printer. See if there's a terrible surprise in the closet or not. Maybe I'll unplug this first. The capacitor in that meanwhile supply should last a while. This dimmer on the lights in my printer that makes all this interference. Clearly, I just have to turn the lights to maximum brightness to make that go away. Anyway. Oh, cool. Len reports that they've been having much better luck with Twitch than with the YouTube streams. Well, I'm glad that's working out, and I'm glad that the stream's working again. Oh, that's a good ask from Peter, who asks, it would be nice to see how subtly the counterweight can be moved up and down. I assume you mean like the spool that I'm lifting? Because yeah, this system doesn't really have a proper counterweight, but yeah, I guess like the weight of the camera. So maybe I'll just run this until the weight is around that same level, and then we can see. Let's put this on manual focus. And plug this back in. All right. So I guess depending on what you mean by subtle, like the actual amount that I can move it is very, very small. I mean, you're really just limited by the resolution of the optical encoder at that point, which is pretty high at 600 counts per minute, or per revolution. In this case, you know, if you were talking about absolute positioning accuracy, clearly that wobble is a problem. I expect you'd see less wobble with multiple anchoring points, but you know, I still expect that in order to mitigate the wobble, I'm going to have to limit my acceleration quite a bit. But I'm just going to try moving it pretty slowly, and I might even have to like look at the console to see when the dead zone actually stops. The other thing is, right now, there's sort of two things I have to overcome. There's a joystick dead zone, which is actually just programmed into the test software that I wrote, so that you have to overcome this particular software boundary before it'll actually start sending any current to the motor. But then there's an additional thing that has kind of the same effect, where you have to send at least a certain amount of current to the motor before it'll overcome the friction and the weight of the spool there on the other end. So that's something where right now I'm kind of having to do it by feel, whereas as soon as I implement the PID controller, then it'll actually be trying to add just enough power to get the motor, or to get the spool to a particular position as measured with the encoder. So once I close the loop, the actual accuracy of, you know, how much I can move the cord will be limited mostly by the encoder, you know, when you ignore dynamic effects like bouncing and overshoot and undershoot. So here I'm just going to try to move it kind of slowly, but as you can see, I can't really ramp up the acceleration super accurately, so I do cause wobble when I start and stop. But I'm just going to try to let off and let it go up just as slowly as I can without it stopping. But then you see, if I let it stop at all, then give myself some more room. If I let it stop at all, then I have to overcome that sort of extra energy it takes to break, friction and the weight that I'm fighting against. Anyway, I'm rambling mostly, but what I'm trying to say is this will be even better at low speeds once I have closed loop control. It gets a little wobbly just because it kind of starts and stops a little bit without the closed loop control. But that's kind of as best as I can do just with my finger. Peter says magnetic encoders. I have an optical encoder already. Optical is really nice for high resolution stuff like this. Bradley asks, I wonder if paracord stretching will become an issue. I am counting on the paracord stretching. That's kind of how I don't want this mechanism to be totally non-compliant. Like, I want something to give for safety, basically. So the paracord seems safer than like a steel cable kind of thing. And I'm not expecting to be able to get absolute position of the robot just by measuring the encoders. The encoders are so that I can have a higher level control loop sending each winch. Oh, you see that? That was a reset. You can see the lights go out and then come back. That was, I think, giving myself an overvoltage. I think I can fix that in firmware. But yeah, my plan was to not worry about absolute positioning at this level. The encoders here are mostly just to deal with the unevenness involved in the winch itself. So the current that I need to give to the motor in order to move the load by a certain amount, the way that the cord winds on the spool. And then at a higher level, actually positioning the robot, I plan on doing that, I plan on sensing the extremes, partly by using the force sensors, but the kind of overall navigation, I think, will be largely based on computer vision. So optical flow, tracking targets, keeping them in frame. Oh yeah, it reboots very fast. So if you saw that reboot that happened earlier, yeah, it doesn't take more than a couple seconds to come back. It's just the power supply cycling and then the microcontroller rebooting. And the microcontroller, like, the longest things that it does at startup are like, I mean, I've actually optimized the startup process on this micro quite a bit because I was doing glitching tests on it, and so I needed to just reboot it continuously. And the thing that I ended up removing that saved the most time was Ethernet direction auto-negotiation. So I think that's actually a lot of the delay you're seeing. Oh, what was that? I don't know why it rebooted that time. I was at the bottom. I think what might have happened is I might have tried to change directions really quickly, which is something I definitely want the firmware to avoid. Anyway, I'll worry about those overvoltage reboots if I see them even after I have some really basic control implemented, but right now, just sending the joystick directly to the PWM, this is kind of in the realm of what I would expect. But yeah, I could just wheel this up and down all day. And it's pretty quiet. I mean, it's probably hard to tell quite what it actually sounds like, given that you're on the other end of a directional microphone, but like, I'm hearing a little bit of that kind of snapping as it winds and kind of skips a layer, which I don't know how much of that I'm going to end up keeping even once I'm kind of winding it more evenly, or how much more evenly it will wind when I'm winding it all under tension. Oh, that was a reset. Anyway, so we've done a few resets. The central control software will know about those because I plan on having a fairly short watchdog timer for all the network packets that are related to the motor control loops. So for example, the winch itself, if it doesn't see a packet from the controller, which right now is the Raspberry Pi, but will actually be probably the same machine that's handling the computer vision, just like a desktop PC. Probably the same machine I'm running the stream off of right now, actually. But yeah, I think part of the firmware that I haven't written yet needs to be kind of a watchdog timer that shuts everything down if it doesn't detect packets from the controller frequently enough. And then similarly, the controller will want to shut everything down if any of the winches go silent. And that's actually how the emergency stop will propagate. So if you hit the e-stop on one winch, then the whole network will shut down because it stops getting telemetry from that winch. Yeah, the thing that shuts it down seems to be changing directions at the bottom while it's still decelerating. So that's fine. That makes sense. I understand why it's dumping energy that way. And when it does do that recycle or that reset, it just means that the mean well power supply is detecting that the voltage has exceeded, I think, 26 volts. It's pretty low. If it goes above 27 volts, I think, then that's when the motor driver itself will start dumping energy. It has a built-in overvoltage safety. And then, you know, the components that I really worry about, like the capacitor is rated at like 63 volts. The DC converter is rated at 36 volts. Motor driver is up there too. I forget exactly how high, but... So I'm not really worried about that being a problem as long as it doesn't happen once my control loop is happier. Anyway, I think that's enough up and down for now. The wiring seems good, and... well, I've got some firmware to write, and a few more of these to put together. Oh, has Tuco... Tuco's been sitting there watching something. Has he been watching the winch move, or has he been just out of frame? No, he's watching something else. Tuco, what are you interested in? I think he's watching a bird or something through the window. What is it, Tuco? He doesn't seem completely disinterested in the thing going up and down. Yeah, I'm for one pretty happy with all the safety features in the Meanwell. That was one reason I grabbed this power supply rather than something else. So I'm certainly not going to complain about the Meanwell having a pretty jumpy overvoltage detection. Yeah, I mean, if anything, the real deal here is that I should be moving the load smoothly enough that this isn't an issue just because I don't want my cord bouncing around. So I'm not super concerned about that. If I need to, I can bodge on some kind of, some kind of diode overvoltage, like, a transient suppression diode kind of circuit to eat up the overvoltage current. But yeah, I think when it's over, well, I'm assuming it's over voltage. It's possible it's over current because I was also potentially trying to accelerate it really quickly while the motor was going in the opposite direction, but it seems more likely that it was just generating voltage and directing that right into the power rails. All right. Well, maybe, I was gonna switch to the cat cam, but you know, I've gotta move the cam because switching to that switched away from what was actually the cat cam. Well, thanks for joining us again. Anyone who joined for both streams, that's pretty awesome. And yeah, thanks to everyone who stops by and supports the channel and in all of the many ways that people do. I really appreciate it. And as always, let me know what you're interested in, if there's requests, if there's stuff you'd like to see, if there's stuff that you think could be done better. Always interested to hear from my viewers. Oh, Peter says maybe you can add some big caps. There's actually already a big capacitor in there. I could potentially add more, but I think I've probably got enough. That was my strategy so far. But yeah. Yeah, thanks for stopping by, everyone. There will be a lot more of this and a lot more cat. There's always more cat. Happy hacking, everyone. What a good cat.